Welcome to this week's demo for GitLab Access Manager or Project FastPass for version 1.11.11. Let's get started. So this week we are looking at our vendor APIs and how we're going to do our API calls to make most of our automations. We did a little bit of pre-work for this in our IT ops scripts. And what that allowed us to do is to talk to each of the APIs without any of the additional overhead of application logic, service classes. We were able to keep things kind of self-contained in a CLI script, but we were able to reuse 95% of that when we moved it into GLAM, and so we were able to do a lot of our heavy lifting in advance. So today we're going to look at how we're using that previous work, how we're porting it over, and how it's going to apply when we look at how we're going to use action scripts, approval flows, action chains, and do all of our automation with all of our database logic for when a user needs to get access to one of our SaaS provider entities, groups, users, roles, through the approval process, and then kicking off the automation and provisioning process. So today we're going to look at the IT ops scripts. We'll look a little bit at Okta. Because of the personal identifiable information in it, we're not going to go into some of the pieces of the demo, but I do want to show you some of the power and flexibility we do have with what we can share on the video today. We also are going to look a little bit deeper at the GitLab API, and I think this is going to be pretty cool, and showing how we can manage users, groups, roles, and more specifically, how we can block and unblock users during the provisioning and deprovisioning process, right? So that's what we're going to look at today. There's other pieces that are intermingled here, but that should get us a good start and kind of show you what's going on here. So if we think about this at a very high level, the action namespace is handling all the automation when we're talking to a different system to tell it to create a user, a group, a role, or deprovision that resource for us. We have automation scripts that if we don't have the ability to talk to that vendor's API or we haven't had time to implement it, we can do the boring solution version in the GitLab way and essentially create either the email notifications, create GitLab issues, add comments to existing issues, or create Slack notifications in different formats that basically allow us to put all of our tech stack applications into GitLab Access Manager early on, even if we don't have all the back-end automation in place yet, and slowly adopt it as we go. It allows us to take a very iterative approach in making this possible. So if we don't have the automation, that's how we're going to handle it, with this more of automating the process of creating the tasks for the system administrators to do it manually, right? So last week we talked a little bit about the SaaS namespace and how that works with what are we trying to grant access to, right? And so we talked about SaaS providers, SaaS instances, groups, users, roles, things of that nature. What we're going to look at now is when we double click on it, when a user gets added to that group, or you want to grant a user access to that entity, what's the approval flow that happens, which we're not going to dive in too deep today, but once the approval flow is completed, where does the action namespace take over for actually doing that provisioning work, doing that automation? That's what we're going to focus on. So I want to show you a flowchart, and this is going to scroll down the page as we go. It's a little bit weird because of how the slides format, but just keep thinking from a top-down approach. So at the very top here, we've got two little kind of call-out bubbles, right? The left side of the screen is defining the template, and this is saying, what do we expect to have happen when we want to run this? And the right side is doing all the records, the resources, and the activities of when we actually run it, what are we actually doing? So the left is the template and the right is the actual transaction, if you will. So the first orange box there is looking at a SaaS instance group. And what we're defining there is saying, for this SaaS instance group, it can have one or more approval chains. And when a user is eligible for that approval chain, it's going to have multiple approval policies that are tied to it. We're not going to spend any time on the details of that, only that some users may have easier access to a system if they already belong to a certain group, or they have a certain role-based entitlement, if you will, whereas others might have a more difficult one. The goal being is, regardless, when you go through an approval chain, that's defining who needs to approve, if it's a user, if it's a group, and all the other criteria. And you can see the documentation for more information. We'll do a demo on that at a later time. But on the right-hand side is we're looking at when it's time to actually grant that user access, the approval flow is essentially the audit trail. And that is the grouping of multiple transactions for person A approving, person B approving, a member of person in group C approving. And basically once that approval flow has been completed, we move down to the action sequences. So keep that in mind. Left side is the template, right side is actually running the template. So this is what happens with it. So as I move down the screen, see how the green boxes have adjusted a little bit. We introduced down here the idea of action chains and action flows. Now, we're going to talk more in detail to clarify what that means, but for the sake of discussion for the moment, the action chain is saying when I'm ready to provision a user for this group and the SaaS provider, what are the series of scripts that I need to run? The action chain is defining the series. The action chain script is exactly all the little itemized pieces, all the scripts or sections of scripts that need to run, all the methods, if you will, the service class methods that need to run to make that provisioning possible. So remember, the left side is our template. So defining when creating a group and a user, what scripts do I need to run to make that possible? On the right-hand side, this is where the action flows are. So following that process of when it's actually time to provision that user, this is taking the action of saying, okay, we're going to start an action flow. Think of this a little bit like a cron job where it's trying to kick off multiple sequence of things happening, or if you have your own script and it's trying to call other scripts, that's what the action flow is doing. The action flow script is the pulling all the metadata for which service method am I going to run, and then what metadata do I provide to it. So we now know what that user is, we know what group they're going into, we have all that metadata. The script that never knew about it, doesn't know. It needs that data as an input in order to make all the automation work, right? So that's the way that this works. And so each of the boxes here are actually database records. And so the action flow is our audit trail of saying, hey, we started the process of provisioning this user at this date and time, and it has child relationships. These are all the scripts that we ran, and each of those has transaction logs of what happened, the audit trail, any errors that happened, success messages, any API data that was returned from that, all that kind of metadata forward, right? So that's what we're looking at here is once the approvals are completed, we move down the flow into approval chains, into action chains, action flows, and work our way further down. Now, let's clarify a couple things here, right? So when you look at what's the difference between an approvable relationship and an approvable chain, each approvable relationship, and that's all the orange components, whether it's a group user, a group role, a user role, all the different components that you could actually create a relationship for. Each of those has one or more approval chains. Now, remember we talked about some users will have an easier time, some users will have a harder time. Depending on what it is, doesn't matter which approval chain you do, there's only one way to provision the user, right? There's only one script you need to run to provision it. And so all the approval chains point to a single action chain. And that action chain is what handles the provisioning process with all the action chain scripts underneath of it, defining which scripts am I running. 90% of the time, there's only one script, right? Sometimes there's a second one where it needs to create it and then send a different piece of it, or maybe it creates a user, then it grants a role to that user, then it grants access to a group or a membership. There's different pieces, and every SaaS provider is a little bit different. So it gives us the flexibility to daisy chain, if you will, those different components together. So every time that you do, you look at one action chain will be the user provision method for that SaaS provider. So that's what we're looking at, right? So with that in mind, let's continue the way down our diagram. And so inside of each action chain script, you're defining what service method to run. And a service method in the programming world is what function are you running, and you're giving it inputs and getting outputs. If you're not technical, or this is a little bit too deep for you, looking at it, it's simply saying if you have a series of runbooks, and you have runbooks are in a folder, and in that folder says, I want to run runbook A, runbook B, and runbook C. And it's a marked-in file or text file with a set of 1 through 10 instructions. Your action chain is the file that has 1 through 10. The action chain script is step 1, step 2, step 3 in 10 different sections. So in this case, if you have a 10-step runbook, action chain is your runbook, action chain script is each step in that runbook. And what it's saying is these are the instructions that a human system administrator would follow. That script is then moved off to a service method where we're making an API call. So instead of sign into the UI, click on the users menu, click add user, and type in their email address, that's now an API call. And so we've specified what is the API call that we're making, what data do we need to pass in, their email address, for example, and then what are we expecting it back. Once their user account's created, go to step 2, grant user rights to this group or to this membership or to any different component. It all varies, right? But that's what we're defining here is all the steps that you normally have in a manual runbook, we're defining with scripts. So this is what's setting it up. On the right-hand side, remember that left side's the template, the right side's the actual thing that we're running, is when we run through the action flow, this is the audit trail. And saying, I'm going to run this runbook, but since a human's not running the runbook, we don't know if it's working or not. So there's audit logs and other components that go into tracking the progress of this, and that'll say it does all the input-output again, right? Where what is the email address we need? That's going to go into the action flow script using the metadata from what group and users going into it. And as you go down the stack, it's simply going to handle all that automation for you. So all this is a glorified runbook that we've automated using scripts and some of the ways that you have to do it in the programming world to make that possible, right? So if that was confusing, that's totally okay. We're teetering here between too deep and just deep enough, right? So the action chain is the template for an action flow. And each action chain is going to have one or more scripts that are going to run. And they're the templates for the action flow scripts. Remember that left and the right side. So in here, the left is in pink, the right is in blue, right? So when we create that SaaS provider relationship, if that's a group, if that's a user, when that's created and the approval flow is completed, the action flow kicks off and all those action flow scripts. And it's going to work its way through those scripts, and it's using ActionChainScripts as its metadata of what am I calling, what script am I running. That's all it's doing, it's just setting up the template to be able to run those scripts, right? Now, if you want any additional clarity, I'm just going to give you one more piece of it just to help paint a picture, is the ActionChainScript is that template, right? We talked about that. For a task to run that specifies which service class and method. And what's inside of that is the API endpoint. It's the API call saying, talk to the vendor's API, provision this resource or create that or get metadata, right? So what you're calling and what data you're going to pass to it. And then an ActionChainScript is going to exist for each of the steps in the process. Now remember, it doesn't matter how the approval comes in. If it's for a different group, if it's for a different user, the API only knows one. So this is allowing us to unify all the variations, all the complexities, instead of having to write a separate script for every team with all the static variables that any variation could be. We don't need that. We only need one. So this does the don't repeat yourself methodology and brings it all together for us. So when the action flow is created using the action chain template, we'll create those scripts using the action chain scripts that are associated. Feel free to go back or forward in this video, look at some of the diagrams, try to connect the dots. You don't need to spend too much time on it. If it's confusing, it's not worth getting into the dirty details. It's really not. Leave that to the engineers. We'll take care of it for you. But this kind of paints that holistic picture of, well, what are these scripts? What's inside of it? And what we essentially do is we end up creating a service class for each of the endpoint groups that exist. And so in general, when you look at an API, and we're going to look at this a little bit in this demo, is there's going to be different endpoints. And so you may have groups. Now, each group may allow you to do different actions. It may let you get a list of groups, get a specific group, create a group, update, delete a group. Those are what are called REST endpoints or REST resources, or REST API, representative state transfer. What that really comes down to is an alternative name for create, read, update, and delete. Which is just a fancy term of manipulate a database record. I want to be able to see a database record, I want to create it, I want to update it, I want to delete it, right? And so what we end up doing is aligning our architecture to how the vendor's API is. When we create each of these classes, it's a file, and I'll show you what it looks like in just a few minutes. We create each of these classes and specify which methods are available as API endpoints. It's usually a one-to-one mapping. There's a little variation depending on what we have to provision. Once that's in place, we can then specify that in an action chain script. All the action chain script is seeing is what service class am I using and what method am I using and what are the parameters I need to be able to get and what parameters am I mapping to. So as an example, if it's the group service, I'm going to need to know the group ID if I'm going to create a user for that group, right? And so those are the different things that we're specifying. So we're connecting from a front-end user interface where you see all the applications, the database that's mapping all the approval flows. The database also maps what scripts I need to run, and then it calls the files inside of our application to run those scripts, passing in that metadata that we told it to. That's the flow that we're working on. We end up creating all of these different classes and services for each SaaS provider. When you look at the tech stack apps that we have a lot of them. It's going to take some time to build this out. And so what we're going to focus on is our core applications and the ones that are, it's the heavy lifters, the low-hanging fruit. We're going to do those first, and then we can simply add more SaaS providers by implementing these services as we go, registering them in the database, and then we're off to the races, right? And that's how we're going to iterate and scale. In the meantime, if one of those applications, those tech stack apps, or SaaS providers are not in our system yet, we can use those manual administration scripts. And we talked about this a little bit earlier with the ability of creating GitLab issues, adding comments to issues. We can do Slack notifications to the system administrators. There's different pieces that we can do in order to offset that, right? So that's what we end up looking at. Now, for a simpler view of this, we can also look at this. And it basically says, whenever we're doing our intake process where we want to add a new SaaS provider to GLAM, what we simply say is, these are the things that we normally do. We need to be able to manipulate entities, create them, delete them. We need to manipulate groups, roles, users, add users to those entities, add users to those groups. And so what we look for is, does this SaaS provider's API support these different endpoints or methods? If they support all of them, great. If it's an easy to use API, even better. Sometimes there's complexity, sometimes we can't do it all. A lot of times some of the more complex functionality in some services is either not available or in a very limited scope that we just have to work around, in which case we can use a hybrid, where we may be able to create users on a service, but in order to grant them to a group, we have to kick off a manual administration task instead. That's just the name of the game. When we're trying to integrate with things, not everything integrates nicely, so we're preparing for all those different variations and contingencies, right? And so that's where those Slack notifications come in. That's where those GitLab issues come in. There's a lot of different variations. This is not an exhaustive list. This will grow organically as we grow. But it kind of gives you a sense and a taste of how we're working with, from the front end, you simply see you're getting access. How does it work in the back end? How are we provisioning all these resources? And so if you're a system owner, or if you are a security analyst, you can kind of get a taste of how we onboard our different users, how we handle those integrations, and how we can iterate without having to build a monolith. We can build everything in small component iterations, right? So that's the benefit that we have here. So with that in mind, let's take a few minutes and we'll jump into the code a little bit and a little bit of the terminal as well. And what I want to show you today is a little bit about how our previous IT ops scripts work. It's not overly complicated. It's actually pretty intuitive, but there's a lot of pieces in there under the hood that allow us to reuse that code. And I want to show you some of the power of that before we lose it, because once we start refactoring, things move, things change. The simplicity may be disappearing a little bit as we embed it in the larger application ecosystem. So that's what we're going to focus on today. So what I'd like to do is let's jump over into the CLI first. And we're going to have a visitor. So Ellie, do you mind hopping down for a moment? The benefits of working from home: your children, fur or otherwise, come join you and while you're working. So let's have a look inside of here. So if we do IT CLI help, this is going to give us all the commands that we have available for us, right? And so if we scroll up a little bit, we're going to see that we do different database commands. We use this for SQL manipulation of some of the things that we import. Fastly, we've onboarded as one of the vendors in here. We also have some GitLab commands in here. We're going to spend a little more time in that today. But it does showcase that we've implemented a lot of the Google API for groups, members, users, etc., as well as Okta. And since Okta is kind of our single source of truth for a lot of our user identity, we have all the integration built already, and so all we need to do is simply import some of it over. So with that in mind, let's have a look explicitly at the GitLab side of it. So if we look at the IT CLI specifically for a GitLab user, is we want to find out, does that user exist, right? So let's have a look at the GitLab username exists command. And I'm going to throw the help flag on here. And what this is going to say is I need to know which instance to check with. In the back end of our IT scripts, we don't want to type in what GitLab instance we're connecting every time. We've pre-configured gitlab.com and ops.gitlab.net, right? Today we're going to look at the ops.gitlab.net and where that user is, and we're going to manipulate a user off and on here. So let's start with doing that now. So if I do IT CLI, I'll actually grab the same command from up top here and do ops GitLab net, and you can see that I'm passing that in from right here. Great, no problem. And then we'll do the username, and I've created one for the purposes of this demo. So I want to find out, does this user exist? Yes, it exists. There's an ID. Does a different user exist? Nope, doesn't exist, right? So now that we know it exists, can we get more information about that user? And so what we can do is we'll change username exists here to get. And if you recall from our commands that we saw earlier, I'll scroll up a little bit and we can look at that. We're looking off of these commands here. So you're going to see username exists right here, and you'll see user get. We're going to look at that, and then up next we're also going to do memberships as well. So we're checking if it exists, we're getting the details, and we'll get a list of groups and projects the user's a member of. Right. All right. So we'll look here. Now I need to change this username. It wants an ID, and that's why it returned. It gave me this ID of 835. So I'm going to replace that and put this in. And now I should get details of everything about this. So this itself is actually going to the GitLab API documentation and saying, what are all the fields that I'm going to return? So if I go and look at that, and I'm on the GitLab API, there's a whole bunch of things in the sidebar of things that could be. Now, if I'm looking at it from a user perspective, I'm running that get command, and this is the response that I'm getting back. Most APIs return JSON. We can manipulate that JSON into objects, arrays. We can handle it in different ways, right? What we've done in our CLI scripts is we simply format it as a table to make it easier for us to visually see in a terminal window. So I've simply parsed out what are all those different pieces. And we'll look at how that works in just a minute. But before we go further, I want to show you the memberships as well, and then we'll have a look at that. So if I change membership from get here into memberships, it's going to go through and say, what groups is this a user member of? For some users, this could be very, very long. If you run it on my production user, it's about 70 different groups and projects, right? But it kind of gives you a sense of what's going on. In our previous iteration of our scripts, we actually detected which groups that were top level groups that we wanted to deprovision from, for example, GitLab-com or GitLab-org. And we could set it up to throw a provision flag on it for when it blocks the user, it gets them out of there, it takes different actions, right? So we can do detection of some groups that we're wanting to get them out of during offboarding. So that's how memberships work. Let's have a look if I want to actually block this user. And so with that, I'll simply pass this in and I'll say GitLab user block. Boom. GitLab user has been blocked as of that timestamp. It's kicked out. There's nothing more to it, right? I can also unblock if I made a mistake. Obviously, we're going to do audit logging and trailing for all these different actions, and the user's been unblocked. Easy enough, right? So that's the way that the different scripts work. That's what's going on as we're working our way through this process. Now, if we have a look at the code, let's ask ourselves, how does this work behind the scenes? But we're going to dive deep for a few minutes. It's okay. Don't worry, it's not too technical. You won't be able to read some of the code just if you're not familiar with it, but you'll be able to follow the concepts of it. And I'll show you why in just a few minutes. So when we look at the command that we just ran, this is the GitLab user get service. And this is where we define, here's what the CLI command is, and these are the arguments that I'm expecting to be passed. You saw that in the terminal window when it parsed it out. It has the ability to make an API call. We can do that right here inside of a CLI command, but we need to actually use a service if we want it to be reusable, repeatable, testable. And the big thing is, depending on where you're using it at, it allows you to extend a lot easier. And so we're actually going to create a new CLI command. We're actually going to create 2 of them. We're going to create them in a few seconds and show you how easy it is to add API endpoints once you have the base scaffolding set up. So in this case, what we're actually doing is making an API call. We're doing a GET request, which is one of the ways that you do API GET requests, HTTP request, to the GitLab user service. And what that's actually going to call, if I go over to the GitLab user service, let's find it here. So so here's the GET request. It's going to call that user/ID endpoint. So remember in our API documentation, here's the user's ID. All that we're doing is simply passing in what endpoint are you trying to do, and our code will handle all the rest of connecting to which instance it is, doing all the authentication, taking care of all the error handling, parsing of the response, all that is taken care of for us. And so all that we then need to do is in each of those services that we looked at in our presentation for the service classes that we create a method for each endpoint. So in our user service today, we've got the get, we've got get by username, get by email. You saw those as other CLI commands that we can do. We got the list memberships, delete, block, and unblock. Well, that's great. But if we look at the sidebar of the API documentation, there's a lot of other endpoints that we can do. So one thing that we realize is we can block and unblock a user. What if we just want to deactivate them? What if we want to take a different action? Let's look at what the API docs are for deactivating a user. And we can see this is what the endpoint is. It's a post. I just need the ID, and I'm expecting a pretty simple response. It's pretty standard. Nothing scary there. What if I'm just going to copy and paste this? I'm going to bring this in. And what we're going to do with this is in our code, we go here, is we're going to add a new method. I'm going to paste this down here so we can use it in just a second. And I'm going to borrow this code block just to make our lives a little bit easier. And we're going to say this is going to be to deactivate. And I'm just for our own documentation, I'm going to grab the URL. So we've got the URL for that. So here's where that is. ID gives it all back, and this is going to be deactivate. So this is how we add a method or a function to our service so we can use this anywhere else in our application. That may be at our CLI, maybe in our web UI, maybe from the ActionChainScripts. It's all these different pieces where we can use it in a very simple approach. And so you notice that all I've done here is port this user's ID deactivate into that. We now have a deactivate method. That's all there is to it. So I can now use this endpoint anywhere in our application. So if I went over to the block method, this is the CLI command that we have. And it's pretty simple in what it does, where it calls that service. I'm going to duplicate this file, and we're going to call this deactivate. And if I go to GitLab user deactivate, I'm just going to rename a few things. In the interest of the demo, I might miss a typo or two where I haven't renamed it. We'll live with it, it's okay. And if we go down, deactivate a GitLab user. And let's see. Okay, we want to change this to the deactivate method. That argument is still the same. Deactivate. And that is all we have to do. We can now use this new CLI command. So if I then go back to our terminal, we'll clear this out, make our lives a little bit easier. And we're going to do the IT CLI help. And we're just going to grab GitLab commands. And we're going to see that now, is that user there? That one is not there. I wonder why. We go back here and look at this user deactivate. It would help if the file name matched the class name. It did not register that class name. Good old programmer logic. Now we do see GitLab user deactivate. Perfect. So what do we need to do to use that? So art to CLI, and we can do GitLab user deactivate. What does it want? It wants to know what instance and what's the ID of the user. We know that already. So let's go ahead up and we'll grab the 835. And we can actually reuse that command from up top. We're just going to, instead of unblock, we're going to deactivate, right? And it's throwing an error message. What message is it throwing? And why is it throwing that message? That is a really good question. This is where demos come in. We can triage this. We can spend a little bit of time. I'm just going to do a die and dump just so you can see how we, on the engineering side, deal with this. Obviously, when you're live demoing, you never know what's going to happen, right? And so if we go into the GitLab user deactivate method here, this is where it's throwing the error at. It's saying that this doesn't exist. What we're going to do is let's just DD and see what this user is. And more than likely, this user actually did deactivate. It just threw an error message on it. So to make our lives easy, I'm actually going to very quickly, I'm not going to do too much explanation, I'm going to make an activate method so we can reactivate them and we're going to deactivate them again, right? Because we don't want to throw the system off too much. So we're just going to have a little bit of fun. We're on a demo, we're here, why not? Let's have a little bit of fun. It'll take about 30 seconds to do. So duplicate this real quick. This is going to become activate. Fix this right up. And as we work our way through here, fix this up. And we're going to leave that DD on here as well, just in case. All right, and on our user service, we do need to add the activate method. It is the same syntax. And so if we jump over here, we'll have a look at the activate. It is another post for activation, no problem whatsoever. Great. And fix our message real quick here. Activate, activate, activate. And get rid of that. Perfect. We've got that in now. Now we should actually be able to see that same CLI command that we just added. And we do see activate now. So we're going to do the same command that we ran a moment ago and just activate that up. And it is throwing another error. What is this error this time? So activate is not a valid method. Obviously, in the case of this demo, this is going to take us a little bit longer to debug, and so we're not going to do that in the case of interest of time. But I think you kind of get the idea of it's pretty quick and easy to create these things. A few things throw an error message here or there. It really varies on what's going on. More than likely, it's something really silly like I didn't save the file or I misspelled it because I can't type. So it's something as simple as that. GitLab user is successfully activated. I can deactivate and see what the response is and deal with that, right? So there we go. That's what the actual API is returning. Is there actually a problem? Hey, what's going on? This is a GitLab error. Hey, the user's been trying to deactivate, has been active in the last 90 days and cannot be deactivated. So this actually is checking from the API side. So when we put in our error handling, that allows us to catch, we want to try this, but the audit logs for that user, when we actually run the action flow script, this is a really good use case if it's going to fail, and it's going to spit back, here's why it failed. That then goes into RBAC, basically creates an alert for us in IT and says, hey, there's a problem, here's what it is, and we can at sysadmin level deal with it. So that's how we consume APIs. This is a really good, kind of shows you it's quick and easy to do. You run into a couple hiccups and speed bumps, you quickly debug them, it's not a big deal. We know what the problem is. We can now figure out, okay, how do we need to exceptionally handle this for this particular method? If it's a 403, if it gives us this message, then add this into the logs. So that's the way that this works, right? And so with that, that kind of shows what I think I want to share with you for today's demo. But it gives you a good taste, right? That's what we're looking at. That's how we're building what we're building. So if you have any questions, feel free to reach out. But it kind of gives a taste of how we're using the different service class methods, the different API calls, and integrating in how we're actually doing the provisioning work of GLAM and iterating through that. So with that, we'll call it a day. Thank you so much for taking the time, and feel free to reach out. Thank you. Have a great